In the oceans, an historic change that's threatening the lives of marine animals. Can science find a way to protect them with the help of this unlikely ally? Here in Maine, biologist Susie Arnold spends a lot of her time on the water. Because her job is to use science to help people like Matt Moretti, who earn their living from the sea.
I work at a community development organization. It's called the Island Institute. We work to sustain Maine's coastal communities. When you think about oceans, they directly impact the livelihoods of the people who live in coastal Maine.
One of the projects Susie's taking on is helping people cope with the change in the world's ocean water that scientists call ocean acidification.
Ocean acidification you can't see, you can't taste, and you can't feel. But this is changing our oceans globally.
Ocean acidification is caused by the increasing amount of carbon dioxide, or CO2, that's making its way into seawater. CO2, that's the product of human activities. When we burn fossil fuels, such as gasoline, we release huge amounts of CO2 into the atmosphere. But nearly a third of it makes its way into the ocean, where it combines with water to form an acid called carbonic acid. The ocean may not feel acidic to us, but this global change is taking a toll on all kinds of shellfish.
Ocean acidification specifically impacts creatures that build skeletons or shells.
Because carbonic acid removes from the water the very molecule, called the carbonate ion, that shellfish rely on to build and maintain their shells, including the shellfish that provide livelihoods for so many people in Maine. People like Matt Moretti. Beneath this floating wooden structure, he and his crew are farming mussels. It's a new way of raising food that's come to be known as aquaculture.
We are a family-owned and operated aquaculture company. We care about the environment, and farming shellfish is the most sustainable form of food production we have ever been able to find. We don't use any fresh water at all, no chemicals, no fertilizer, and no feed. The only thing we do is provide a protected environment for our crops to grow, and it's a way of adapting to a changing world.
As the crew sorts through the mussels, they have to pull out any that have broken shells, because a mussel whose shell is broken is likely dead, and therefore inedible, so it can't be sold.
The harvesting and processing of a mussel farm is very rough. Shells are going to break. Shells are going to break a lot more if they're thinner and more brittle. That can be a result of ocean acidification. If the Gulf of Maine is becoming increasingly acidic, is it possible for a shellfish farmer to do something to adapt in the years to come?
To try to answer that question, Susie has been working with another scientist, an old friend of hers named Nicole Price. They first met when they were graduate students.
Nicole and I both studied coral reefs in graduate school. She studied in the South Pacific, I studied in the Caribbean.
Because Susie and I shared that history together, we were able to link up right away as soon as I moved to Maine and decided to go out for a bit of ice cream together and just share histories of where our careers had been and where we were going.
And they discovered that they shared two common interests: ocean acidification and an organism that they both suspected might be able to do something about it: seaweed.
Most people, when they think of seaweed, kind of get the ick factor going. They imagine the slimy stuff on the rocky shores that they slip on, or what entangles around their feet as they're trying to jump in the waves.
But to Nicole and Susie, in the fight against ocean acidification, seaweed is a potential game changer. Because seaweed takes in carbon dioxide, a key step in the biological process called photosynthesis, which is as vital to seaweed as breathing is to us.
If you think about seaweed, it's photosynthesizing similar to a land forest, and it's taking out excess carbon dioxide from its environment, which is the seawater around it.
Their fascination with seaweed led Nicole and Susie to launch an experiment using a kind of seaweed called kelp. In many places around the world, people raise it in underwater farms and sell it as a food crop. Here in Maine, there are dozens of kelp farmers. What Nicole and Susie wanted to know was how much CO2 a kelp farm actually removes from the water, and whether removing that amount of CO2 lowers the water's acidity. So in 2016, a few miles off the Maine coast, at the site of a local kelp farm, they began a 3-year study.
The kelp is grown at 7 feet under the water. It grows from the size of a pinhead to over 12 feet in length over the course of the winter.
Using a submersible sensor, they compared the acidity of the water inside the farm with the water in a nearby control region.
What the data showed after year 1 was that the pH is higher inside the kelp farm. That means there is decreased acidity inside the kelp farm.
After 2 more seasons that showed similar results, Nicole and Susie were ready to find out if kelp farming could reduce the water's acidity enough to help shellfish. In 2018, they started a new experiment with Matt Moretti and his mussels. They grew some mussels within the kelp farm and others nowhere near the kelp.
What we found was incredibly exciting, and incredibly exciting for mussel farmers. Those mussels that were grown for only 2 months inside the kelp farm actually had thicker shells, they had denser shells, and they had bigger meats.
It was exciting to the aquaculturists, to the mussel farmers, because there was the evidence that they were looking for to make some decisions about where to invest in the future.
The land farming industry has existed since the dawn of civilization. Farming the ocean is like an infant compared to that, but we've made, as an industry, incredible jumps, and that's all based on science.
Science is applicable to everyone. It matters to everyone. Bringing industry minds and scientific minds together to solve real-world problems. What's important to me as a scientist is to do science that can help people to continue to make a living off the water.